Good morning, good afternoon, good evening, ladies and gentlemen. Welcome back. It's another 2 hours of the Kev Baker Show right here on Truth Frequency Radio. And you can find us now at tfrlive.com. Really liking that shorter, snappier kind of web address. I can get easily used to that. But don't fear, because if you've got the old web address saved in your browser, stuff like that, Mr. Geo has set it up so that you all get redirected to tfrlive.com. It's all seamless. Absolutely love it here. And of course, if you hadn't heard already, yes, that's right, I am going for 2 hours every night right here on KBS. And of course, Johnny Whistles, he will be along later on to join us. He's still doing his training for his new job. Proud as heck of that guy. I really am. It's really hard to get employment these days, especially when you've been out of the workforce. So, you know, big up to Johnny for doing that. And the fact we get any of his time at all, to me, honestly, folks, it's an absolute bonus and a pleasure. And of course, there's a third member to this team now, every Monday and Wednesday. And I join forces with him on a Friday. You guessed it, it's Anthony Patch. But there may be some people out there who haven't heard of Anthony Patch. So he's an author, a speaker, and a researcher. He's a host here on the network. I like to call him the world's leading CERNologist. He's the guy that really has educated most of the world about the true power and the true science of what is going on at the LHC over in Geneva in Switzerland. Better known as CERN, he also introduced most of us, I would imagine, to the D-Wave quantum computer and all the fun and games and shenanigans that goes along with that. He's the author of a number of books: Covert Catastrophe, 2048, Diamonds in the Rough, Revising Reality, and I'm helping him, just on the peripheries of helping him, put together something that has turned into an absolutely amazing project. And this is, of course, Entangled E-Magazine. Tony, this month's edition, yet again, sir, absolutely amazing. Hats off to you. There's a bit of a download from yours truly in there, but people can find that over at anthonypatch.com. And I tell you, man, you must be putting in some hours putting all that together, Tony.
Well, it's not just me. I want to say a big thanks to you, because your download into this now 100-page magazine is nearly a book. And what I asked you to do was to go back, because you're an excellent writer yourself, and pull from your archives the 12 best articles that you composed from our interviews over the years, and include those in the August issue of Entangled magazine. And they are beautiful and brilliant. And if new listeners to the show want some background on CERN, particle physics, DNA, all of those good things that Kev and I have talked about for almost 3 years now, you'll get a really good foundation, as well as current information in the 12 articles that are contained in the 100-page Entangled magazine. So thank you for your hard work and your excellent writing skills, my friend. And a big, big shout out to Robbie and Cheryl, who are the publishers of Entangled magazine. They're the ones that make it look beautiful. They're the ones that put in all the long hours to make it happen. I'm just kind of the ringleader in this three-ring circus, and I really want to thank the people that have contributed as writers themselves to the August issue and the July and June. And some of the people are right here in the chat room that have contributed their own beautiful writing skills and research. So it's not just Kevin and myself. What we do is provide a platform, a venue for those that might not otherwise have a voice to be able to come to Entangled magazine and spread their opinion, perspective, research, and voice to the world. And I encourage anyone who's listening to this show today to contact me through my contact tab at anthonypatch.com and submit your articles. I'll take a look at them, see if they fit into, sort of our framework of what we're trying to achieve there. And I welcome all, and we'll just take a look at it. So thank you to everybody, and thank you, Robbie and Cheryl, for your huge professionalism. This is top-notch magazine production. Beautiful, beautiful project and product they put out this month.
No,
Take it away, my friend.
Yeah, I was going to actually just second that because you know I like to play about with the Photoshop. And believe it or not, when I first got Photoshop, I couldn't even use the thing, right? But to see the kind of finish and the glossiness that Robbie and Cheryl have put to this, I've been blown away by it. The covers of the magazines alone, very striking, so professional looking. And when you add to that the information inside coming from real people and scientists and all sorts of others as well, then it really does all add up to a pretty special publication altogether. Now, Tony, over the time, right, that we've worked together, you have used a word over and over again that I really hadn't heard much. Maybe Alex Jones, he's probably the second biggest user of this word in the kind of on the airways, but hubris, this word hubris, and I know a lot of you out there listening tonight, you followed Anthony maybe from the start or you've picked up somewhere along the way, and he's often referred to hubris. Well, tonight's show is called Hubris, Cracking the Theoretical Paradigm Egg. And I dug up the actual dictionary definition for hubris today, and it's so apt, so fitting, because its first kind of definition is excessive pride or self-confidence. And some of the other words that you could substitute and use in its place are arrogance, conceit, haughtiness, pride, vanity, self-importance, self-conceit, superciliousness, feeling of superiority. And there's others as well, but then it goes on to say as well, and I think this is very apt, because when they used hubris in the Greek tragedy, it actually meant excessive pride towards or defiance of the gods, leading to nemesis. So this is a word that Tony has used over and over again. And Tony, like I say, you've almost made this word as infamous as Geordie Rose.
Well, thank you for that. I call it being full of themselves. That's my definition.
I mean, when I seen the actual definition, I had a rough idea of what it meant, but excessive pride or self-confidence. And when you look at these pompous so-and-sos when they're putting forward their ideas and their theories, no better term befits these people.
Yeah, thank you. I agree. And I love one of the definitions you just read, superciliousness. You know what it made me think of is superstring theory in particle physics, as well as supersymmetry when we talk about not only particle physics, but quantum computing. So maybe we should just call tonight the Supersilliness Show.
The Supersilliness Show. That fits for us, Tony. It really does. It might get super silly, but I can guarantee there's going to be so much information contained in here. It's going to blow your mind. And we're going to start off tonight because we're taking a kind of shot at the theoretical paradigms that are out there. And one of the biggest theoretical unicorns that exist in science, and we've spoke about them so much, and I've referenced them. I've said black holes here, black holes there. Well, tonight we're going to attempt to kill the black hole, or at least offer an alternative. And I'm going to read out a story here as well as I can. Anthony's going to interject when he hears things that makes him drop off his chair. But what this is actually saying is that this year, because of the telescopes that they've now got trained on the center of the galaxy, they're basically taking images of the void at the center of the galaxy. Now, it's just commonly assumed that that void and all the others like them at the center of any other galaxy in the universe, it consists of a black hole. But always remember that black holes are theoretical. We've never, ever seen one. So with that said, New Scientist this comes from, and it's actually the author of the story is Stuart Clark. And it says here, fascinating, bamboozling, vaguely terrifying. Black holes are the love-to-hate monsters of the universe. The insatiable cosmic cannibals are concrete predictions of Einstein's general theory of relativity, the best theory of gravity that we have. Even so, theorists long debated whether they could exist, until astronomers saw the first signs of them. Now we see black hole paw prints all over, in huge stars collapsing in on themselves, in distant collisions of massive objects that set the universe quivering, and in the dark hearts of galaxies, including our own. This year, we should have the clincher. The first direct image of the supermassive black hole at the Milky Way's centre. But as we gear up for that shadowy mugshot, some physicists are entertaining a maverick thought. What if it isn't there? The new word is that our obsession with black holes might have blinded us to the existence of something even stranger, a basic phenomenon of particle physics whose significance we have failed to grasp. After all, there's good reason to want whatever is at our galaxy's heart not to be a black hole. For a start, black holes make a nonsense of quantum mechanics, the best theory of everything besides gravity that we have. It's a speculative idea as yet, to be sure, but there are sound reasons to contemplate it. Quote, we scientists tend to be completely arrogant about what we think we know. And that was a theorist called Luciano Rezzolla of the Frankfurt Institute for Advanced Studies in Germany. He goes on to say that I don't want to find myself in 10 years' time saying that it was just another arrogant, overconfident scientist. For all their contemplations, the basic notion of a black hole is remarkably simple. In general relativity, the magisterial theory Einstein produced in 1915, massive objects bend space and time around them, creating the force that we call gravity. An object with sufficiently large mass, densely enough packed, bends space and time so much and creates a gravitational field so strong that nothing, not even light, can escape once it crosses the event horizon. The black hole is a celestial lobster pot, with the difference that it never gets emptied and just keeps on accumulating lobsters, no trace of which is ever seen again. The fact is, no one knows how black holes work on the inside. Relativity suggests that anything that falls in will be crushed by the black hole's gravity into a singularity of zero volume and infinite density. But the prize is still out there for anyone who can say what that truly means. Meanwhile, theorists' most refined calculations show that black holes must either destroy information, which is a complete no-no in quantum theory, or surround themselves in a seething mass of energy called a firewall, which breaks the tenet of general relativity. Black holes represent the point where the very large, the domain of general relativity, meets the very small, the domain of quantum theory, and the results are not pretty. Such problems were already becoming apparent in the 1960s, but that didn't stop astronomers imagining ways for nature to produce black holes. When a massive star's fuel was spent, for example, it might collapse under its own gravity into a stellar mass black hole. Such an object, by its nature, would be pitch black and almost impossible to distinguish from a pitch black cosmos, but could make its presence known in other ways. And sure enough, in 1964, a huge outpouring of X-rays was discovered in the constellation Cygnus. They labelled this Cyg X1, and it looked exactly like the models of radiation emitted by superheated gas plunging down towards a black hole. By the 1970s, astronomers felt confident enough to proclaim that Cyg X1 was almost certainly a stellar mass black hole eating matter in its surroundings. That wasn't the half of it. In the early universe, when giant nebulae were collapsing to form galaxies, the gas at their centres would eventually become dense enough to form monstrous, supermassive black holes, each weighing as much as 1 million or even billions of suns. The invisible object at the centre of the Milky Way, known as Sagittarius A, is thought to be just one such black hole. It was identified in the 1970s as a particularly strong source of radio signals. Subsequent studies, particularly of the way its gravity pulls nearby stars around, have continued or have convinced us that it is indeed a black hole with 4 million times the sun's mass. Further convincing, but still circumstantial, evidence for black holes came last year with the announcement of the first detection of gravitational waves. Yeah, whatever. These ripples in space-time emanate from very massive objects that are accelerating. For example, two bodies spiraling inwards to smash into each other, for example. The signal observed by the LIGO collaboration in September 2015 was exactly that predicted for the collision and merger of two stellar mass black holes. LIGO has since seen two more signals, each compatible with the merger of stellar mass black holes. So is that the case closed? Not so fast, says Rizzola. Quote, although the presence of a binary black hole system is an obvious and simple explanation, it's not the only explanation, he says. In particular, the signals might not come from black holes, but from an entirely different theoretical invention. Now we're going to get into something called boson stars.
Okay, let's hold it right there if we can.
There you go. I can get a drink now, Tony.
Yeah, that was a long dissertation, my PhD friend.
Well, what do you think of that so far? We've got gravitational waves, and now we're moving into another theoretical monster, the boson.
Yeah, I think what we'll do is do some definitions, which is what we always do. This is our trademark, is to define so that people understand what is being tossed about in this article. And then after the break, which we have coming up in 9 minutes, we're going to get into the other part of that article, which is the boson component of it. And that is a paradigm shift. I just want to set the stage. It appears that mainstream science is hedging their bets and about to move into a different definition of black holes. So before we get into that definition, we're going to backtrack a little bit. So let's talk about light, because in the discussion of black holes, and I will set the stage here for that as well, is that black holes are theoretical. Picture the blackboard and the chalk and the equations. That's where black holes live, on the blackboard of theory. Now, we can talk about Einstein, we can talk about relativity, we can talk about gravity, all those wonderful things around the theory. Never been proven, never been replicated in the laboratory. Therefore, in an empirical fashion, which is the basic foundation of all modern science, empirically, they've never been proven to exist. They're still theoretical. With that understanding, when you talk about black holes, they talk about gravity being so profound, the density of the object being so profound that the gravity waves are such that even light cannot escape. Well, let's define gravity and let's define light. Gravity, first of all, in comparison to magnetic lines of force, electromagnetism, the electric universe model, is 10 to the 39th power weaker than electromagnetism. Now, electromagnetism, we get into talking about light, visible light, the electromagnetic spectrum, which includes X-rays, as you mentioned. So when they say that light cannot even escape the gravitational pull of a densely packed object, we have to understand that light is composed of photons. Photons do not have any spin. Spin is their angular momentum, and they are massless. A photon is a wave. Now, there's the theory of wave-particle duality, in which a particle can also be a wave can also be a particle. Let's set that aside just to make it clear and concise and say that a photon has no mass. If a photon has no mass, then gravity cannot be part of the discussion, because gravity only operates where there are particles with mass that gravitationally would attract each other, but only attracting at 10 to the 39th power weaker than the polarity. the charged particle state of the matter having mass. It's either positive or it's negative. So to say that photons are held in place, light is trapped gravitationally by a densely packed object, whether it's composed of bosons or not, which we'll get into, they are violating their own theory by saying that light cannot escape. Well, of course, light cannot escape. The reason it cannot escape is because magnetically it's held to the object. It's charge state. It has no mass. It's a wave. So electromagnetically, just think of a magnet attracting something that's metallic. Make it really simple. If it's a wave, has no mass, gravity does not factor into the discussion. That's just one piece of it. But go ahead, Kev.
Now, I want people to understand just how big a shift this could be, though, because like we were saying when I first told you about this, Anthony, I mean, this is a huge paradigm change. The fact that they're even entertaining the idea that it might be something else as opposed to the black hole, because like we were saying before the show, it's ridiculous that so many of these kind of institutions and really esteemed scientific places, they still hold true to this Big Bang and all that kind of theory, black holes included. Yet, like you were saying, so many contrary theories out there from reputable scientists as well, yet they still harp on about Big Bangs and black holes. So when I see the New Scientist, which is very mainstream, folks, this is very mainstream. They dip their toe into politics. They really are. I mean, it's like the agenda. It's always climate change and global warming, stuff like that. We're killing the planet. For them to make this kind of bold move and put out what is one of the biggest articles in this month's publication, and in fact, the front page itself, the cover says, "Goodbye, black holes. We're about to see one for the first time, but what if it's not there?" So, Tony, I really hope the listeners get that this is some really deep, heavy science, and it's fundamental to everything, because we could be looking at a great unified theory here. They were talking about how the theory of relativity doesn't work with quantum physics, but if you take black holes out the equation, then there could be an actual theory of everything.
Yeah, it could be. And we'll get into talking about the bosons, which is a class of particles, quantum particles. But what I want to emphasize before we go to the break is that Einstein's theory of relativity got into this whole discussion of gravity bending light. Now, light, again, as I've defined, so that everybody knows the basis for what we're talking about. If light, which is photons, which is just an energy wave, it doesn't have any mass, then how can light be bent by gravity? That was the essential cornerstone of most of Einstein's work, was the theory of relativity. So here's what I will offer to you. In the model of the electric universe, light is affected electromagnetically by an object that has an opposite polarity. So the bending of light is done using a magnet rather than gravity, because there are four fundamental forces in the universe. One is gravity, which is 10 to the 39th power weaker than a magnetic lines of force, electromagnetism. So how would light be more likely bent as it's observed? And it is proven that light does get bent as it travels past a very large, dense object. And that's a given. And that was proven during an eclipse during Einstein's lifetime. So that's fine. They proved it, but they assigned it to gravity rather than electromagnetism. And that's what's been obfuscated from the general public. That's why Tesla is not held up as the standard. They want people to believe what Einstein was putting out relative to gravity, pardon the pun. And that keeps everybody ignorant from what they're really doing. and that is what Kev Baker and I have been doing, is to remove the veil and show the true model of what is going on in the world of quantum physics. Go ahead.
You know, a good way to finish the break here. Cheryl in the chat room. You can find us at tfrlive.com/chat. She nails it. Albert Einstein was asked how it felt to be the smartest man on Earth, and he said, I don't know, go and ask Tesla. We'll be back after the break. Don't go anywhere.
This is the Kev Baker Show.
Welcome back, everyone. I'm Kev Baker, and you're tuned in to the Kev Baker Show right here on tfrlive.com. I'm joined tonight by my good friend and co-host on a Monday and Wednesday, and I do the same for him on a Friday. It is, of course, Anthony Patch. Find his work over at anthonypatch.com. Now, before I forget, tomorrow night we'll be joined by a man just as close to me as Anthony is, and that is James Swagger. We all got to love Mr. Swagger when he used to come on regularly on his expeditions. He was like Indiana Jones, and he is back out and about in Central Europe as we speak. He's going to be coming on tomorrow night. He's going to be getting into things like the rhesus blood issue, that monkey blood thing, that thing that leads people to think there's been some genetic engineering or tinkering in the past. We're also going to be talking about space as well, because James has been noticing a lot of talk about Planet 9, and that's got him looking at a whole host of topics that you are going to absolutely love. And that's all tomorrow night, right here on the Kev Baker Show. Now 2 hours, of course. We're moving into the second part of hour number 1, and we're getting into some really deep and heavy, important science tonight. And I suspect a lot of you out there are loving this, because Anthony, we all know Anthony through his work on CERN. I'm pretty sure most of us were introduced to the big man when he was covering CERN, going around all the biggest talk shows there are. And he was the guy who educated us more than the mainstream ever could about what goes on there. So I know that that core audience that you've built up, Anthony, they love it when we drill back down into the science and offer, well, opposing opinions and opposing theories, because, you know, they give their theories, and why shouldn't we? But tonight we're dealing with black holes, and I'm going to get back into this article from the New Scientists. And I left it where they kind of put the idea out there that let's forget about black holes momentarily. Maybe they've blinded us. Maybe we've missed something. And that something might be boson stars. So it goes on to say, let's back up a bit. The fundamental particles that make up most matter, you, me, those supposed black holes, all belong to a class known as fermions. Their signature characteristic is they obey the Pauli exclusion principle, which says that particles cannot occupy the same quantum energy state as one another. The Pauli principle explains the appearance of the material world. It determines how electrons arrange themselves in different energy states around an atomic nucleus, and thus the properties of the various chemical elements. Now, bosons are a different kettle of fish. The Higgs boson, discovered to great fanfare in 2012, is perhaps the most notorious example. It provides matter particles with their mass. Other bosons carry the forces that allow matter particles to interact. Bosons aren't exotic. In fact, we see them all the time, quite literally. Photons of light are bosons. The thing about bosons is that they can cram together with virtually no limits. Rather than forming some kind of uncontrollable subatomic mosh pit, they become what is effective, or what is in effect, a collective particle, a state of matter known as a Bose-Einstein condensate. We know how to make Bose-Einstein condensates in the lab. We also know that, given the right bosons, there's nothing to stop them forming something bigger on scale, perhaps much bigger. Some physicists even think they can form stars, although not as we know them. Quote, when we say star, we are basically just saying a collection of stuff that holds together, says Steve Liebling of the Long Island University in New York. When normal matter forms a star, gravitational pressure heats it so it ignites into a nuclear fusion, pouring out light. In contrast, boson stars would just hang about like cosmic couch potatoes. Donut-shaped couch potatoes, in fact. Simulations suggest that if boson stars rotate as conventional stars do, then centrifugal forces would give the bosonic matter that form. These celestial donuts would be transparent, emitting no light of their own. They would be invisible, and the primary thing that would give them away would be their intense gravity. Sound familiar? Boson stars could mimic black holes, says Leiblin, and it is possible that we are being tricked. The idea of boson stars isn't anything new, but astrophysicists pooh-poohed it because no one could think what sort of boson might be used to make one. The particles such as photons that transmit the fundamental forces just don't cut the mustard. But then came along the discovery of the Higgs boson. It revived interest in novel bosons, not least because they could be a boon for particle physics. That in turn has spurred physicists to ask how we might seek evidence of boson stars. LIGO is one obvious way, although the current detector can't tell whether gravitational waves come from two black holes merging or from two boson stars. The place to look for the difference is not in the pre-merger phase, the inward spiraling that gives out the waves observed so far. Rather, it is in the aftermath, when the two objects have coalesced and are still quivering from the shock, like a rung bell. Quote, as with bells, each object will have its own frequency and tone, says Rizzola. Black holes of a given mass will have their own tone. Boson stars will have another. Unfortunately, LIGO is not yet able to hear this ring-down signal with sufficient precision, and upgrades will let it do so are probably at least 5 years away. The Event Horizon Telescope, an international project to look directly into the maw of a black hole, might deliver clarity sooner. Radio telescopes across the globe have been wired up with the aim not just of detecting emissions from Sagittarius A as superheated gas spirals across its event horizon, but actually the mapping them out. Do that with enough precision and the shape of the black hole itself shows up. Well, a black hole in the middle of the image, that is. This is a tall order, the equivalent of sitting in London and taking a picture of a mustard seed in New York. For that reason, Heino Falk of Radboud University in Nijmegen, the Netherlands, who is one of the driving forces of the Event Horizon Telescope, cautions against overexcitement, although he is enthusiastic about the data gathered so far. It's not going to be a beautiful, sharp image. It's likely to look like an ugly peanut, or perhaps an ugly donut. Opinions differ as to whether it will be easy to distinguish between images of a black hole or a boson star. Calculations by Frederick Vincent of the Paris Observatory in France suggest that the gravity of a compact boson star will bend light around itself, creating an empty region that could be mistaken for the shadow of a black hole event horizon. Again, quote, a boson star is really different to a black hole, and yet still it produces features that look like a black hole and smell like a black hole. Rizzola thinks this analysis is overly pessimistic. Like a black hole, a boson star will be sucking in matter from its surroundings, but the boson star's transparency means this matter will be visible at its center. It is also likely to heat up and start emitting light or some other form of electromagnetic radiation. This light might remove the presence of a shadow altogether. Vincent agrees the behavior of matter inside a boson star is an area that needs investigation. It's a program of research that I'm trying to develop. We are developing the codes to do this from scratch. Now, Falk is not expecting any surprises when the first image from the Event Horizon Telescope finally comes together. Quote, I am afraid it is nothing other than a boring black hole. The choice of words indicate just how deep-seated the belief in black holes now is. Even those working on boson stars admit they are a long shot. I am open to arguments, but they are still pretty exotic. And that comes from that chap libeling again. And just to finish off, it says here that then again, the reward for killing off black holes is potentially immense. Embodying the conflict between general relativity and quantum theory as they do, they are a massive roadblock to progress on an overarching theory of nature. Put like that, it seems this is a puzzle where keeping our options open would be wise. It's always best to stay open-minded, says Rosola. Then let the experience tell you what you really have there. And doesn't that fly contrary to what scientists do all the time, Tony? Because they always theorize they're out there without any evidence to support it.
I am encouraged to hear that some of these guys are open and they're being contrary to the mainstream politically correct dogma, let's call it dogma, about gravity and about black holes. The unfortunate thing, even in this shift from that party line, they're still using gravity. So let me back up and kind of take apart this article, and I'll ask you to kind of jump around with me in the article to read those sections. But go back to the part where they were talking about tones and frequencies, and they were talking about it relative to electromagnetism. Okay, so they're saying that there are emissions of tones and frequencies. Can you read that part for me?
Yeah, and it's talking about how to differentiate between the boson or the black hole, and it says LIGO is one obvious way. Although the current detector can't tell whether gravitational waves come from two black holes merging or two boson stars, the place to look for the difference is not in the pre-merger phase, the inward spiraling that gives out the waves observed so far. Rather, it is in the aftermath, when the two objects have coalesced and are still quivering from the shocks like a rung bell. As with bells, each object will have its own frequency and tones, says Rosola.
Okay. All right, let's stop there. Again, we're defining because we want to break things down for people. When they are talking about tones and frequency, they're talking about electromagnetism. That flies in the face of their theory of gravity being associated with even two black holes merging together. And when they merge together, what they produce, what they radiate, if you will, if it was gravity that brought the two together and thus resulted in the emissions, then the emissions would not be electromagnetic. They're saying that they are electromagnetic. Therefore, the source of the attraction has to be electromagnetic. So it's important when people read articles like this, or, two geeks like Kevin and myself read an article like this, that we really be critical thinkers and look at the words, look at the context of what they're talking about here. It's almost like they're doing double talk. They're talking out of two sides of their mouth at the same time, because tones and frequency not only produce X-rays and gamma rays and produce photons as well, visible light in the non-visible areas of the electromagnetic spectrum, but they also, in that article, said that it's producing heat. Okay? Heat is not produced by gravity. It is produced by charged particles. Heat is part of the electromagnetic spectrum. So you cannot say that two black holes coming together using gravity result in electromagnetism. No, you have to start with electromagnetism as the attractive force that then results in the emissions in the broad spectrum of electromagnetism itself, which includes heat and light and gamma rays and X-rays. Now, they mentioned Sagittarius A, again, as being an example of the center of the universe or the center of a black hole, Sagittarius A being a theoretical black hole. even that is producing emissions of gamma rays and X-rays. Again, electromagnetism. So we're just trying to emphasize to the audience, they're only giving you half of the equation. They're only giving you half of the explanation. They're still sticking to black holes, but they're trying to sidestep it, and that's good news. They're trying to sidestep over into talking about bosons, which are particles. It's a family of particles. Again, the Higgs boson. Now, Kev, in that article, they cited the weight, and I have no notes with me today. The interference is preventing me. I'm just being nice here. The interference with my computer is preventing me from opening any additional browsers to quote numbers from, but I believe the weight of the Higgs boson was 125 giga electron volts. Isn't that correct?
Spot on, my man. Spot on.
Okay. So we're talking about a massively heavy particle. Now, if black holes, we can put a different name to it, and I haven't quite put a name to it myself. Maybe we'll call it hubris. How about that, Kev?
I think that's perfect.
It's a hubris hole. All right. Boy, I'm going to get in trouble that way. Anyway, moving right along, if you have a dense particle, then that's heavier than, a proton or an electron, but certainly heavier than an electron, then you have the ability to have charged states of heavy particles pulling each other together, attracting, I should say, each other. Think of what happens when you compress matter together just in our everyday lives. It causes friction between the mass, between the particles, between the molecules. You create friction just by rubbing your hands together. That's what we're talking about here when you produce heat and gamma rays and X-rays and even light. It comes from that friction that comes together not because of gravity, but because of oppositely charged particles coming together. I'm going to go again and say a great foundation for you for all of this information is the Thunderbolts Project. They're the ones who've put together this whole electric universe model. These are legitimate scientists doing legitimate work, research, and laboratory experiments. And I'm not a spokesperson for them. We're just simply reflecting the discoveries and the proofs that they've come up with. And they're operating outside that hubristic world of mainstream science. They definitely are not politically correct in that regard. Go ahead.
This electric universe, I mean, correct me if I'm wrong, but there's streams of charged particles flying around, and then you get these areas called Z-pinches, don't you? And that's where you get the formation of stars. And is that planets as well?
Yeah, exactly. And you had a great article in this month's August issue of Entangled magazine in which you were talking about the Z-pinch that we discussed, I think, back in 2015. And that is the ionized gas that is filling, quote, the void of space. It's actually filled with plasma, the fourth state of matter. And when you have plasma that electromagnetically is gathered together, much like this black hole scenario of gravity attracting matter into a dense, compact area, what you're having in the formation of a star is the crossing of the streams. It is a crossing of oppositely charged particles in the form of Birkeland currents, which are twisted helical structures of oppositely charged particles. You have Birkeland currents that are crossing, and they form a nexus. They form a center point that then magnetically attracts more plasma. This is how the sun, our own sun, was formed. That is what powers our sun. It is continually attracting more plasma into itself to power the sun. Now, this has been proven in the laboratory by Monty Childs and his team and the Sapphire Project, and we've discussed that many times. What I'm saying to you is that this idea of the electric universe, the universe being filled with plasma, the gathering of plasma magnetically resulting in this heating and this emanations of gamma rays, X-rays, and photons, and the whole spectrum of electromagnetism is radiating out from this gathering of plasma that results in not only stars, but also planets. But we're focused on talking about stars and nebula and the theoretical black hole. Go ahead.
And of course, never lose sight of the fact that the boson star itself, it's highly theoretical as well. It's just an opposing or an alternative theory to, like they said, and I like the fact the guy actually admits this, that when you're so convinced that something is one thing, that you can lose sight of other things that it may be. And it's almost like we were talking about the other day, Anthony, the kind of topics we cover some of them from the long view out, because there's so much other stuff out there, other information, that it can come along and you have to change your worldview, you have to change your theory. But sometimes these guys in science, they've got the blinkers on. I used to say that it's like if you imagine them right up at the microscope, they've got their eyes right on it, and they're seeing that one thing in so much detail. That's brilliant. But they're not seeing everything else that's going on in the lab around them, and it could hold so many answers.
Yeah, in fact, you just described some statements that I made in my first book, Covert Catastrophe, as to the psychological blinkers, as you call them, the blinders that are on, because they're so compartmentalized, they don't see the bigger picture of what their research is resulting in. But let me step back just a little bit into this article, because you were talking about the Bose-Einstein condensate, and I do think that it's worth just mentioning, because there is a correlation to Bose-Einstein condensate in terms of the cosmological scale and D-wave at the quantum scale in terms of how qubits operate, as above, so below. So I'm going to pull that together. I think it mentions in that article the temperature of the Bose-Einstein condensate. As I recall, it's about negative 275 degrees Kelvin. Now, maybe it's not in that article, but that's my memory serves me correctly. What I'm getting at here is this is the lowest state of matter. It's the coldest. It's the near 0 point of temperature in which there's no energy. And again, to define energy as heat, as temperature, think of the movement of electrons as energy, as what we would consider and define as temperature, but it's really the movement of electrons. If you're slowing electrons down, if you're slowing particles, quantum particles down, including bosons, down to where they have very little movement, then you have very little energy, you have very little temperature, if you want to put it in a human frame of measurement. What I'm getting at here is that the lowest state of a black hole means that the black hole, the matter that has gathered, did not gather due to gravity. If you compact them because of gravity, you generate heat. But as they're defining the boson as a probable explanation for a black hole, then they have to come together electromagnetically and at their lowest state, slow in order to condense. To be closely packed means they have to be devoid of energy. In other words, they cannot be vibrating. They cannot be moving around. To be as closely packed as they theorize a black hole to be, in that nothing escapes, including light. If that is their working model, then it cannot be gravity that brings these particles together. The particles can only remain closely packed if they're not vibrating. In other words, if they're at their lowest energy state, they're not moving around. That's how they become closely packed. If they're not vibrating, then they're not giving off photons. So how about that? And to relate that to D-wave, D-wave operates at a super cold state, and their computations are run in an environment, in a textured landscape, in which at the bottom of peaks and valleys, at the bottom of the valley is the lowest energy state. And at that lowest energy state is where they extract their resources. They grab the resources from parallel dimensions. They extract or gather their solutions. Their computational solutions are derived from a lowest energy state. What I'm saying here is that the way the quantum computer operates is the same way that a better model, the electric model of a black hole, if you want to call it a black hole, operates. So let's say a black hole is the same thing as the quantum computer. How about that, Kev?
It's a hole of hubris, Anthony. That's what we're going to call them now. But what I find really interesting about this kind of alternative theory with the boson star is that it would appear exactly like a black hole does. And what I mean is there would be much light escaping from it. They would see radiation coming off it, and it would just be sitting there like a void in space. And they admit it has all the same characteristics. You know, if it was a crime that was committed, this boson would have the same kind of facial features that would fit the photo fit of the suspect they're looking for, just like the black hole does. So I'm glad, I really am glad that at least talking about this in the open and considering something alternative, or as we prefer to call it here, the truth. They're actually getting close to the truth. Dare we say it? Now, we're going to be back after the break. I still love saying that. I'm always going to love saying that. And joining us after the break, the man himself, Johnny Whistles, is here. He'll be with us just when we come back. I'll let him bring us in for part 2. Don't go anywhere. We've got a lot more paradigm-changing science to get into. This is Kev Baker's show. Don't go anywhere.
This is the Kev Baker Show.
Hello and welcome back to the second hour of the Kev Baker Show, here with Mr. Kev Baker himself and the genius that is Anthony Patch. And it's going to be a fantastic second hour. And just before we go to Mr. Patch, a big shout out to Naga Ward. It's his 30th birthday today. So have a good one, brother. But
oh, man.
Kev, it's over to you, mate.
30? I would love to be 30 again, dude. I could drink then. I could go out partying. Like I was saying to Tony before the show, I'm like a toucan Dan now. About 2 drinks is my limit, and that's me out the game. But happy birthday to Naga out there. Great phone call the last time we opened the phones as well. It was absolutely brilliant speaking to you, and I hope you've got a brilliant day lined up. I really do, Naga, and we appreciate you and everyone else tuning in here again tonight, because it's because of you we all come back night after night, because you lot out there, you make it worth it. You literally are the lifeblood of TFR, and we never ever want you to forget just how much we do appreciate that. And that comes from me, Johnny, Tony, and all of the hosts on the network. And tonight, I've been loving this. We've been getting into some real hard science, but it's been necessary because there's so many theories that are out there that are just taken for granted as being fact, yet they are just theories. We started off on black holes, and I offered up an alternative coming from the New Scientist, no less. Boson stars. They look like a black hole, they walk like a black hole, they talk like a black hole, so they could literally be the same thing that we're mistaken for black holes, right? Maybe not, but at least we're keeping our minds open to it. And Anthony has become famous now for the fact that he really likes to define things. And that's really, really important for all of you out there, because then you're not left in some kind of state where you're wondering just what he meant. Nothing's ambiguous. Everything explained. And Anthony, you like interacting with the chat room. Absolutely brilliant crowd in there tonight. They're loving the science. And it's a question from there that you want to get into now. It's relating to CERN and black holes.
Yeah, as an alternative. So if we're talking about black holes and we're kind of debunking them, then what's the alternative to a black hole? And let's refer back to the article, because again, they're talking out of both sides of their mouth at the same time. It's like there's 50% of it I think is leading in the right direction, and 50% is going off in the old school of still talking about gravity. So I want you to refer back to and read for us the piece in which they are describing the center of this boson model black hole as being clear. So if you'll go to that portion, I'm going to describe in terms of CERN, the Large Hadron Collider, what is going on at CERN that is very much like what they're describing in their, quote, boson model. And then I'll tell you what a black hole, what we're calling the hubris hole, perhaps really is. Go ahead.
Oh, I'm sitting here laughing. I'm trying not to let it go out on air, but we talk about our entanglement, right? And this is like a 4-page article with multiple columns on every page. There's pictures, there's diagrams strewn throughout it. And I'm sitting with my finger on the exact bit that Tony tells me to go to. That's how it works around here. But anyway, it says here, when normal matter forms a star, gravitational pressure heats it so it ignites into nuclear fusion, pouring out light. Now, in contrast, boson stars would just hang about like cosmic couch potatoes, donut-shaped couch potatoes. Simulations suggest that if the boson stars rotate as conventional stars do, then centrifugal forces would give the bosonic matter that form. These celestial donuts would be transparent. Emitting no light of their own, they would be invisible. And the primary thing that would give them away would be their intense gravity. Does that sound familiar? Boson stars could mimic black holes, Tony.
Yeah, I'm going to agree with them in this particular part of the article, and that is because when they say that the center, okay, hanging about, okay, like a couch potato, what that means is Bose-Einstein condensate, super cold, no energy, no movement, closest packing of matter together in their lowest energy state, therefore it's not emitting light. That scenario we talked about just before the break. So as the couch potato model, I would like to say to Naga, your birthday cake, Naga, for your 30th birthday, is a bundt cake. Now, a bundt cake, if people don't know what that is a circular cake that has a hole in the middle. So this model of the bundt cake it is transparent in the center. That's the new black hole, the hubris hole. Then this is exactly what is going on at CERN. And I'm going to explain how this hubris hole is formed. And that is, if it is transparent in the center, it is therefore a toroidal field. They even said it's much like a donut. Well, that is exactly describing a toroidal field. If you look at it, it looks exactly like a donut. We have a toroidal field surrounding this planet from the north and south poles. That's the magnetosphere and the magnetopause. Those are our shields. Those are our electromagnetic lines of force that surround the planet and forms the shields along with our atmosphere to shield us from electromagnetic energies, diffusing and refracting the entire spectrum of electromagnetic energy, visible light, X-rays, gamma rays, right down through the whole spectrum, are shielded and filtered and refracted so that when we observe them on the planet's surface, they're weaker, they're diffused, even their frequencies and wavelengths are shaped and affected by our atmosphere. So with that kind of overview, let's go to the Large Hadron Collider, which itself is a ring. It's a ring-based synchrotron particle accelerator. Just reviewing for people who haven't heard this before, there are particles that are accelerated that move in two beams, two streams of particles that move in opposite directions from one another at near the speed of light, 99.99 the speed of light, because if they cross the threshold to the speed of light itself, spontaneously these particles, which have mass, would spontaneously convert to energy. Okay, so they don't want the energy, they want to keep them as mass so they can cross the streams and collide them and fracture them into small quantum particles. Now, with that background, let me make it very clear, and we've said this before, Kev, but it's for people who haven't heard it. When you move particles, when you accelerate particles through a magnetic field, just like they do in the pipe, as they call it, in the ring of the Large Hadron Collider, that movement of particles through a magnetic field produces at right angles to the movement of those particles, right angles to their pathway, are magnetic lines of force. It's called orthogonal projection of magnetic lines of force. Those magnetic lines of force are what produce the donut-shaped toroidal field around the Large Hadron Collider itself. Now, I said years ago that what the Large Hadron Collider is a model of a black hole. However, I did not call it a black hole because I've never adhered to that theory of a black hole. What I'm saying is that they are producing what they have obfuscated, what they have hidden by using the gravity model rather than the electric model of the universe. They have hidden from the public the fact that what they're doing is modeling the real formation of the hubris holes at both the earthbound terrestrial level as well as at the cosmological level. It is the donut shape of magnetic lines of force produced by these movement of accelerated particles in the collider that also occurs naturally in the cosmos within the field of charged particles moving through a magnetic environment, which is the ionized gas, the plasma. You have charged particles in the form of Birkeland currents. They are oppositely charged particles moving in a twisted helical pattern, much like the human DNA, observed by Hubble telescope, being thousands of light years in length. This is what we're talking about. Charged particles moving through the plasma is the same thing that happens at the Large Hadron Collider. And because it's the same thing, you produce magnetic lines of force at right angles to the Birkeland currents. When you do that, you create the donut, the toroidal field. When you form the toroidal field, you form the hubris hole, which is transparent in the center because it's a donut. And therefore, you have this gathering of matter electromagnetically, not gravitationally, and in the cold environment of the lowest energy state of the Bose-Einstein condensate, you now have the closest packing of matter, which they want to call the gravitationally attracted black hole. Wrong. It is simply that this is the lowest energy state of the matter within the transparent area of the donut of the toroidal field naturally produced in the model of the electric universe. Take it away.
Absolutely love it. And I can even add to that because Anthony's talking about how this is almost cosmic, the kind of things that are happening down at CERN when you've got these particles going through the magnetic fields, curving their way through there, because they do. They throw off light, they throw off X-rays, they throw off gamma rays. And we can prove that because they've got an experiment, not the Awake experiment that we spoke about many, many times on here, where they do use plasma. But there's another experiment called Cloud. Now, this is quite an old experiment. It's been running for some time. But what they do there is they've got a cloud chamber. They mimic and make false clouds in there. And then to model how the cosmic rays from the sun and from space interact with clouds, what they do is they have a chute coming off from the actual main ring that takes all of the light, all of those X-rays, which they call cosmic rays, because it's exactly the same as the cosmic rays in space. These are the things that are being produced when you accelerate the particles around CERN. So just like Anthony and so many other people say, as above, so below. And that cloud experiment, I mean, that's blatant proof that this is cosmic radiation that they're producing, Anthony.
Yeah, it really is. And I'm just answering some questions in the chat room as we're going here. So I'm kind of being schizophrenic here for a moment. But yeah, I think that what we need to understand is that this article is beginning to show, I think, the influence of the younger scientists coming into the mainstream world of scientists and saying, wait a second, maybe not so fast, guys. And you need to think of this differently. You need to begin to acknowledge the electric model of the universe, because there's so much information coming out of people like the Thunderbolts Project, and we are adding to that discussion, you and I, Kevin, Johnny, that they're beginning to say, hey, wait a second. There's a large number of people in the truther community and beyond that's beginning to understand that this is the Tesla model of the universe and not the Einstein model of the universe. And so they are starting to leak this out so that they do not look like they're the, I don't want to call them criminal, but that they've been covering up the real model. So I think they're just kind of leaking this out to say, well, yeah, we're kind of going that direction. And yeah, we're starting to agree. And we're starting to say, yeah, this is what we've always been doing. And evidence of that is the Awake Linear Accelerator at CERN that we spent so much time talking about, which is pure Tesla technology. Go ahead.
And Johnny Whistles, I'll bring you in here, right? Because I'm really encouraged when you see these scientists kind of opening their mind to some of the new stuff that's going on, because we've often spoke about the black holes and stuff like that. And if we do have these new younger generation coming in, Johnny, we often focus on the downside, the negative of science. Could be encouraging to know that there's a new wave coming through that are going to really turn things on their head.
It sounds fantastic, Kev. It's probably what's been needed for a long time. And as you say, the younger generation out there that are actually looking to see what is out there, how far it is, how big it is. It's great to see them come through, because I'm sure we've got a lot more scientific evidence of what's actually in space, Kev, from this community. So I hope it works really well, mate.
And think about it as well, Johnny, right? Because we've had the likes of Anthony Patch coming along. We've had the Electric Universe guys over at Thunderbolts Project. They've been on the go for a while. And then even more kind of amateur as well, we've got the likes of Dutch Sense and Suspicious Observers, right? Now, all of the people I've mentioned so far arguably are putting out, and I'm talking statistically here as well, if you were to look at it, better science with more results and more hits than the mainstream, air quotes used there, Johnny. They must actually be quite embarrassed by the fact that with all the money that they have, it's guys like Patch, Thunderbolts, Dutch Sense is predicting earthquakes, John. You've got Suspicious Observers. He's doing things that those SOHO satellites and things, they would love to dream up, right? But this is the world we're living in now, and it is like a new kind of paradigm change.
Yeah, and it can't come quick enough, Kev, because you said those people that you mentioned, even including Anthony Patch there, do you know what I mean? Some of the things that, the science that is being reported by, this is, you won't see them on the TV, this is the thing, but you will get in your face actual up-to-date info of just what is happening in the world, not just what's happening in space. So hats off to every one of them you mentioned, Kev.
Absolutely. And Tony, you've got the likes of Dutch Sense, right? He's got a track record predicting the earthquakes. You yourself, you put out theories, and what always blows my mind with the theories you put out there is the fact that these are all out there in the scientific community. It's not like you're making the stuff up, you're coming up with it in your own house or anything like that. It's some experiment you've done. These are from published papers, and you're drawing that information together and coming up with things that turn out 9 times out of 10, I would say, probably to be more correct than anything we've been told by the mainstream. And that must hurt them. It must really hurt them.
I think it does. And, we're not trying to attack the guys individually and personally. We're just saying that the system they're operating in and the system that literally puts food on their table, they're beholden to. And this is oftentimes many of these experimental projects that you and I look at, and the papers that arise out of them, the peer-reviewed papers, really are nothing more than just jobs programs. Let's look at it this way. Military-industrial complex. You have many, many industries, including very small mom-and-pop companies that support the military-industrial complex. Well, the same thing operates in the world of science. You have literally thousands upon thousands of companies of large and small scale that support things like the CERN activities and other laboratories around the world. Massive infrastructure. And therefore, you have to keep the funding going. You have to keep the structure there. You have to have the factories, if you will, operating all the time. You can't just shut them down and then try to start them up again when you're going to do another experiment. So you have to keep the momentum going. And that's part of just the socioeconomic reality of mainstream science, just like you have with the military-industrial complex. So anyway, here's the deal. I want to kind of go where we started at the beginning of this show today, and that was them being full of themselves, this whole notion of hubris. You know, oftentimes people like you and I, Kevin, Johnny, when we get into talking about science in the manner that we do, the pundits will throw the label of pseudoscience at us and other people that produce books that are contrary to mainstream scientific thinking. Well, let's do the famous and now infamous 180 on them. Okay? Let's spin this 180 degrees around and say, okay, you guys label yourselves as theoretical physicists, theoretical astrobiologists. Okay? Excuse me. Let's take astrobiologist for a moment and take that apart. Astro implies the cosmos, if I'm not mistaken. And biologist has something to do with life forms. Well, have life forms been proven to exist even on our moon, the closest object to the Earth? No. How can you call yourself an astrobiologist if there's no biology? How can you call yourself a theoretical physicist when you're using the word theoretical? Theoretical implies something that has not been proven. It is only conjecture, a hypothesis. And yet you could run around with the name theoretical in your job title and be very well paid for all of your own hubris, for all of your own nonsense. All right? So if you want to say Kev Baker and Johnny Whistles and Anthony Patch are preaching pseudoscience, well, guess what? It's theoretical, just like your mechanism and your practice. So you guys are full of yourselves. Go ahead, Kev.
Oh, I'm going to give myself the title, and there's no hubris in this because I'm a hypothetical quantum physicist. You see, it doesn't even make it to the theory stage, Anthony. I don't write it in a paper to be tested or anything. It's just the inner workings of my mind. Just a hypothetical quantum physicist. I like that, John. But you know what Tony said there? So simple, so basic. Astrobiology. I know we talk about aliens and, again, Johnny, all hypothetical and theoretical to us because we haven't seen one personally. But isn't that interesting? Astrobiology. The biology, life, and space. They haven't got any. Brilliant.
That is, I mean, what a fantastic way to put it, Tony. So even these theoretical physicists, it just amazes me that somebody can actually get around, do you know what I mean, and be very successful in something that they think is there, but we don't know So we'll just theorize that it's
Sure.
there, and this is how it works.
They just come up with ideas.
Yeah,
They're idea engineers, Tony.
They are. They're idea engineers. And what distinguishes them from you and me? Well, let's see. It's a PhD. Well, I call that a piled high and deep piece of paper, okay? Because their degree and multiple degrees are based upon mainstream science. Mainstream science is based upon necromancy, okay? Things like that. And alchemy. We said this 2 shows ago, Kev. If you know your history, then you know exactly what everything is built upon here specifically in technology today. Mainstream science is built upon alchemy. Now, as far as I'm concerned, alchemy is pseudoscience. So, you want to say that we are pseudoscientists? I'll take the label, because we are theoretical just like you. And people like Tesla, I consider Kev and Johnny and myself to be in the same camp as Tesla, in that we are critical thinkers, we are free thinkers, we use our imagination, we use our creativity, we think outside the box, we look at things from a rational standpoint, and we do not practice necromancy, communicating with the dead, gathering information from fallen angels using things like a quantum computer. Thank you very much. That is a modern form of necromancy, obtaining data from fallen angels in a waterfall of data, compared to what Dee and Kelly were doing in the late 1500s. The point here, folks, is it is all pseudo. It is all theoretical.
Absolutely.
So
and forget them graduating, Tony. They should actually be ordained into the Church of Pseudoscience.
Thank you.
The white coats, they should give them a dog collar, because it's not PhD, it's CPS, Church of Pseudoscience.
Beautiful. Beautiful. Well, we called ourselves a long time ago, the 3 of us doctors, didn't we?
Oh, we certainly did. And that's definitely a high time I threw about that Photoshop into the chat room again of the day we fired up the quantum time machine and made it into the Vatican vault. You know the one, guys. Come on.
That was some picture, that one.
I think it's accurate. And so they can go ahead and scream and yell pseudo at us all they want. I don't care.
We are on the break, guys. Can you believe it? There's only one more segment to go. Lots more to come. We're going to be getting Tony's thoughts on dark matter and cryogenics. Stay tuned.
This is the Kev Baker Show.
We are back already. Wow, this has gone quickly tonight. This is the Kev Baker Show. I'm Kev Baker. Got Johnny Whistles with me. And of course, it's Wednesday night. We have got Anthony Patch. You can find his work over at anthonypatch.com. Now, Johnny, I'm coming to you first of all for this segment, because we're sticking with science. And I think we've both agreed in the past that the TV show Wayward Pines is absolutely amazing. However, some of the science contained with that is equally terrifying. Now, one of the major kind of tenets or cornerstones of that whole story is the fact that people freeze themselves for thousands of years using cryogenics. Now, cryogenics, it's nothing new. They've spoke about using cryogenics for deep space travel. We've all seen that in the movies as well. They travel for years asleep and then they get woken up. Voila, everything cool. But in the real world, it doesn't really work like that. And Johnny, you're not a big fan of the cryogenics per se, are you?
No way. Kev, I mean, who in their right mind would actually go for this thing? They've been trying to do it for 60 years, and they've still never managed to figure out the defrost process of the human body. Now, they say that it's a breakthrough with nano rods, gold rods that go into your body. I don't get it. They've only ever managed to do this with zebrafish embryos. So I don't know why anybody would choose to do it. But, Kev, on the subject of fish, I took my goldfish to the vet the other day, and he said, "What's wrong with it?" I says, "I think it's having epileptic fits." He says, "It looks quite calm to me." I said, "Well, you haven't seen it outside the tank yet."
Oh, only you, Johnny.
Oh, well.
He just says it so deadpan and then just sits back down, mutes up, back to work.
Sure. Yeah, that's okay. For the folks out there that don't know this, Johnny's fish is named PETA.
Yeah, but it thinks my name's Bob, because every time I go near the tank, it's like, Bob, Bob.
Oh, whistles. Well, before this descends into something like a scene from Monty Python, which wouldn't be a bad thing, right? Let's get back to the cryogenics. And Johnny, all the best to your fish, man. Make sure it's in best of health, okay? I'll be checking up on the fish tomorrow night because the listeners out there will want to know, right? But we're on cryogenics. And John, we've often almost laughed at the fact that it's not really much use because they can't suss out the way of bringing things back to life. So it's just like throwing yourself in a deep freezer. Oh, we could be wrong though, Johnny, because like you say, there's been major breakthroughs. And of course, cryogenics, it was in the news earlier this year in the UK because there was a cancer victim who was going to get themselves cryogenically frozen. I've got a quick clip here, and then we'll get into how they're actually making breakthroughs with this science.
It's very interesting and very complicated, and interesting to know that this young girl was researching this the entire time. So I want to just put up the steps for you on the screen so that you can see them as we go through it. Most importantly, the body needs to be declared legally dead as quickly as possible after the clinical death. That way they can begin cooling the body. And also, the blood is flushed out and replaced with a special non-toxic antifreeze to prevent ice crystals from forming in what would be, that would cause damage to the blood cells. Then after that, the body is packed in dry ice for transportation. In this case, it left London and went to a facility in Michigan. And there the body was placed in a storage tank filled with liquid nitrogen, and that was on October 25th. So from October 17th to October 25th, all this is happening.
So there you go, folks. That's the basic steps. Now, that sounds like the preparations for mummifying an Egyptian or something, but it goes on to say here that these advancements are being made because what they're using are, when it comes to the antifreeze, there was a problem with that. The major breakthrough has come by adding another solution. And this is where it gets interesting because they add gold nanorods. It says when the minuscule rods are added to the antifreeze, lasers are shot at the frozen embryos, which were frozen to 196 or minus 196 Celsius. The nanorods conduct the laser's heats, allowing the embryos to be warmed up much quicker. Now, Anthony, I'm going to come to you on this because here we are, they're talking about you being declared dead and then being prepared for this cryogenic procedure, which up until the introduction of nano gold particles wasn't really a goer, but now it looks like they've had a breakthrough. What's your thoughts on all of this? Because bearing in mind, we speak about science and necromancy with the dead, all this kind of stuff, and now they're throwing gold into the equation.
Well, this takes us back to ancient Egypt and the process of mummification, because the process of mummification is similar, if you will, to this whole idea of cryogenically mummifying a body. It's not a matter of temperature. It's a matter of using monoatomic gold, what they called the gold that was considered to be sacred. It was considered to be the life fire, if you will. It was gold that they would actually sprinkle in the form of dust on the bodies during the mummification process of the pharaohs. And they believed that the monoatomic gold, the sacred fire, as it is described, would result in the ability to reanimate the DNA. Now, I'm going to make a quick explanation of this because we've talked about it before. Nimrod's DNA Nimrod's head specifically, according to the Egyptians, according to the legends, according to what has been passed down since we invaded Iraq, is that the head of Nimrod, the Tower of Babel creator, was preserved in a clay jar surrounded by monoatomic gold, the sacred fire, and that was taken to the Vatican and will be taken to the north area center point of the main ring of the Large Hadron Collider within CERN, and that they will reanimate, they will resurrect the DNA of Nimrod. And this ties into the monoatomic gold scenario. So it's not cold, it's not cryogenic, it's literally the DNA that they will resequence, because we've talked about sequencing of DNA and the in silico DNA, the modeling in the computer, and then building from scratch using that sequence. Therefore, the sequence of the DNA of Nimrod and resurrecting him in the north area, when they also simultaneously open the doorway to the abyss, utilizing 20 peta-electron volts of energy, at the same time that all of this connects to the southern pole of Saturn, unlocking the prison cube within Saturn and allowing that connection to act as a conduit between Saturn and the opening of the abyss at the same time that they resurrect the DNA of Nimrod. Now, all of that sounds completely insane, but all I'm doing is reflecting to you the historical record. Go ahead.
Absolutely brilliant. And that there, ladies and gentlemen, is how you go from Johnny's fish to resurrecting Osiris in about 6 degrees of separation, only on the Kev Baker Show. I absolutely love it. And Whistles, you are a legend, my man. You really are. But Tony, we're going to be debunking more science quickly before the end of the show here. And something we often come across is dark matter, dark energy, all that kind of talk. What's your thoughts on that?
Well, they claim that dark matter, dark energy, that they have a camera now to detect dark energy. And again, dark energy, like dark matter, has never been detected. Therefore, it's never been measured, never been empirically reproduced in a laboratory, and therefore never proven. So again, it resides only in one black area, dark energy and dark matter, and that is on the blackboard.
Same as the black holes, consigned to the theoretical blackboard. I've got a story here that ties in with this camera that Anthony's talking about. It says dark energy camera reveals 23 young galaxies that appeared just 800 million years after the Big Bang. Astronomers have peered millions of years into the history of the universe, and it still always boggles my mind how they are able to do that. And of course, it's because of the speed that light travels. But anyway, revealing a glimpse at an era known as the Cosmic Dawn. Using the powerful dark energy camera, which is situated in Chile, researchers have spotted 23 young galaxies as they appeared 800 million years after the Big Bang, when the universe first began to transform from darkness of its birth. During this time, the universe underwent a process called reionization, in which the energetic radiation from the first galaxies and stars illuminated their surroundings to effectively burn off the fog obscuring young galaxies. Now, an international team of researchers, including astronomers from Arizona State University, used this DEC, the Dark Energy Camera, at the National Optical Astronomy Observatory, the 4-meter Blanco telescope, to observe the galaxies from the cosmic dawn. Now, roughly 300,000 years after the Big Bang, the universe was dark and full of neutral hydrogen gas, according to the researchers. The first galaxies and stars began to appear in the next 500 million years, and as they emerged, their radiation ionized the space around them, causing the universe to transform. Experts estimate this process took place roughly 300 million to 1 billion years after the birth of the universe. And he goes on to say here that, quote, before reionization, these galaxies were very hard to see because their light is scattered by gas between galaxies, like a car's headlight in the fog. As enough galaxies turn on and burn off the fog, they become easier to see. Now, Tony, here we are, dark energy cameras. Are we buying into any of this?
No. And let's define reionization. That's the cornerstone of what they're just talking about there. Now, ionization means either adding or subtracting electrons. In this case, they're talking about hydrogen and helium. Now, if you strip away electrons, you end up with an ionized gas. The ionized gas, as I said, that fills the void, so-called void of the cosmos, is the fourth state of matter, which is plasma. So in this statement you just read, they are acknowledging the electric model of the universe, the plasma that exists, in their model of the universe insofar as how it was created, which is the Big Bang, which I absolutely do not adhere to. Some people in chat were asking about this. The Big Bang, even with many, many scientists have said and debunked the black hole scenario. It is a process of replication of tetrahedrons. We won't go into that because we don't have any time. It is not a Big Bang explosion. It's a process of replication. So reionization simply means that you're starting with hydrogen, which this has been empirically, it's been tested in the laboratory, reproduced, measured, so valid, a converting of hydrogen to helium. Now that is valid. Now when you talk about, the cloud, the headlights in the cloud, you're talking about just the dispersion of the concentration of the gas to the point where if we have to focus on light is able to pass through. It's just the density of the matter. It's the density of the gas. But reionization is no big deal. It happens all the time. It's a fluctuation of energy levels. It's a fluctuation of electromagnetic processes. When you strip away an electron to form an ionized gas, that is done electromagnetically. It's not done with gravity. So I'm agreeing with them, but I'm saying why I agree with them is because of electromagnetism. Go ahead.
So, Johnny, here we go. We've got dark energy cameras, man. Dark matter, all this kind of stuff. Your thoughts on this, John? Because, like I always say, you're my cosmologist.
No, Kev, I don't know about that. But, I mean, the things that we're talking about, dark matter, dark energy, the Big Bang. Now, it's good that they're actually using the electric universe model to do calculations. I mean, that's great. The one that got me is how do they actually know? I mean, what caused the distance between 300 million and 1 billion? That's the kind of mathematics that I would love to know what they use, because that is a hell of a long time in history.
When you think about it, Tony, though, I mean, it's a bit of a guesstimate when they're throwing out such a large field to kind of play with. 300 million to 1 billion years ago. So really, we don't have any clue.
Yeah, again, pseudoscience in the, quote, mainstream. They can throw all kinds of numbers around because they're in the priesthood, and they are the only ones who understand the mathematical trigonometry that is going on the blackboard. They're the only ones who know all the symbols on the chalkboard, right? So it's their priesthood, and they cover it up in these elaborate theoretical formulae, okay? And unless you can read it, you don't realize that it's piled high and deep, PhD. It's all nonsense. All of these symbols that they scribble on a chalkboard represent theories. Each one is shorthand. That's all that math is. It is shorthand for theories from previous pseudoscientists. Whether you want to talk about Galileo, you want to talk about Newton, talk about Einstein, it doesn't matter. These are all built on theories. Yes, you can build a atomic reactor, build an atom bomb. You can build an automobile. You can do your quantum mechanics. But it is all built on theories. So if you have a machine like a atomic bomb that results from your mathematics, that's all well and good. But you know what? That's a rather imprecise way of going about, because all of this stuff is an experiment. That's why they call them experiments. They really don't know what they're doing, including at CERN. Their own people we have quoted so many times saying, this is a new realm of physics. This is a new area of physics. We don't really know what's going to happen. And they talk about opening a doorway to other dimensions, their own words. And they don't really know what's going to happen when they send something through the doorway and what the result that comes out of that doorway will be. And yet they'll do it. Same thing with the atomic bomb. They set off the first bomb at Trinity, and a lot of the scientists were afraid they were going to ignite the atmosphere. They really don't know. What I'm describing to you folks is doing science with a sledgehammer. None of this is precise. Don't let the equations on the blackboard fool you. It is all theoretical. It is imprecise. And they don't know what the actual results in the physical world will be. It's all experimental and theoretical and pseudoscience. Thank you very much.
They are all ordained into the church of pseudoscience. You know, I'm going to coin that phrase, guys. I really am. But here we go, right? Just under 8 minutes to go. We don't have enough time. Where does the time go? And I know I've just started a 2-hour show, and here I am now struggling for time again. I am loving this. I really am. And Tony, before we go tonight, I'm sure we spoke about this on Freaky Friday or somewhere else, but it kind of ties in. It's science and it's an experiment that a lot of people in the alternative research community have looked at. But it's this thing that they call the Philadelphia experiment. Now, they say Albert Einstein was a part of it. Rumoured that Tesla was there too. You've got the USS Eldridge. You've got magnets. You've got a ship that disappears, reappears, comes back again. What's Tony Patch's take on what you've seen about the Philadelphia experiment?
Well, I think it is, as far as I know, I think it is legitimate. I think it is factual. It is based upon Tesla's work with DC current, extremely high voltage DC current. Again, we're dealing with electromagnetism. You're dealing with the ability to warp the fabric of space. And this gets into the whole time, matter, even light discussion. And we don't have time for that tonight. But I think that there was a warping, not so much of time, but of the physical space, the physical matter that was warped. And we can define warping as simply changing the density of materials from the electromagnetism that resulted from the high DC currents that were being produced on board the ship.
Well, little Lulu in the chat, she's asking what the Philadelphia experiment is, and I'll dig up the wiki kind of bullet points on this. And I love when this happens because I love giving people new stories, new information, new rabbit holes to go down. And I remember the first time I came across this one, this blew my mind, and it was the Philadelphia experiment is an alleged military experiment that's supposed to have been carried out by the U.S. Navy at Philadelphia Naval Shipyard in Philadelphia, Pennsylvania, sometime around October 28th, 1943. Now, I think the story goes, guys, and Whistles, I'll get you in here, right? Because were they not trying to, or they say they were trying to create some cloaking device because they were at war at the time. The Germans were taking out ships with their U-boats. They wanted cloaking. Is that what the kind of public face was, or what they said, John?
Well, I think it was a public view.
As public
yeah.
as
Yeah, because, I mean, it was top secret. But, I mean, as we've heard, Kev, who knows what happened, but the stories say that it turned up in another port, and then when it came back again, some of the sailors were actually infused into the metal, which couldn't have been a very pretty sight, Kevin. It must have been extremely painful. So a few people died in this, and it was just probably one of the craziest experiments that I've ever heard.
Yeah, I think Al Bielek, he was the one that kind of blew the whistle on this. And Tony, this is me hypothesizing here, right? You were talking about a change in the density of the particles and things like that. So we hear about stories, rumours that there was people merged with the hull of the ship and a whole host of monstrous things going on. Is that because the density, they kind of like a soup, they blended together when they were in that state, and then whatever happened, they're ripped out of that state back to solid, then the two things are intertwined? Is that theoretically how that would work?
Yeah, because if you have fluctuations in the magnetic attraction of particles of matter due to the DC currents acting as an electromagnet, and you have fluctuations occurring because the generators were disruptive and they couldn't maintain a consistency of the DC current. And with the current fluctuations, you have a fluctuation in the magnetic forces, and that results in the mixing of matter, which unfortunately were human bodies and metal.
And of course, we're Team Tesla on here. No, not the Musketeer. The actual real Tesla, Nikola Tesla. And it's rumoured that he was there, and Johnny, I see you in the chat, put this as well. And I don't know if this is true or not, but I would like to think so, because when Tesla sat down and looked at the math of what they were trying to do, John, he kind of looked at them as if they were crazy. You guys don't even know what you're playing with here. Now, whether that's right or wrong, I don't know, but interesting, John, right?
All right. Well, Kev, I think anybody that would have seen that experiment probably would have seen it. But here we're talking about an absolute genius. And if he turns around and says, "What do you think you're doing?" Do you know what I mean? Then I think you have to listen to him. It must have been honestly a horrible thing. Do you know what I mean? If that actually happened, it really must have been horrible.
Well, it's another example of the sledgehammer approach to doing a scientific experiment, which again is nothing more than what they did with the atomic bomb. Those are sledgehammer approaches to things. That's the same thing they're doing with the Large Hadron Collider, literally a sledgehammer. Hey, can I put in a quick plug here, Kev, before we run out of time?
Oh, yeah.
I'm offended you asked. Go ahead, my good man.
Hey, September 16th and 17th, I will be hosting my very own live stream conference, or forum as we like to call it. Kev Baker will be a part of that. We're going to have guest speakers. We are going to be presenting this for 2 days, and there's more information that can be found at anthonypatch.com. But this is going to be a very, very different conference than I think anybody has ever presented yet in human history. How's that?
Oh, and I am not going to give anything away, but I totally concur with Mr. Patch. I hope you've enjoyed tonight. You haven't had the church of pseudoscience from us guys. We've basically put out an alternative theory for the black holes, not ours, but coming from new scientists, the boson star, something for you to go away and think about. We've talked dark energy, we've talked black holes, all sorts of stuff. Johnny's even throwing his fish in there. And I can guarantee you there's been more real science on here tonight than you'll find anywhere else. And thank you all for joining us. We'll be back tomorrow with 2 more hours on KBS, wherever you are. Until then, make it TFR.
And then he touched that dial.
God bless you all.
When a massive star's fuel was spent, for example, it might collapse under its own gravity into a stellar mass black hole. Such an object, by its nature, would be pitch black and almost impossible to distinguish from a pitch black cosmos, but could make its presence known in other ways. And sure enough, in 1964, a huge outpouring of X-rays was discovered in the constellation Cygnus. They labelled this Sig X1, and it looked exactly like the models of radiation emitted by superheated gas plunging down towards a black hole. By the 1970s, astronomers felt confident enough to proclaim that Sig X1 was almost certainly a stellar mass black hole eating matter in its surroundings. That wasn't the half of it. In the early universe, when giant nebulae were collapsing to form galaxies, the gas at their centres would eventually become dense enough to form monstrous, supermassive black holes, each weighing as much as 1 million or even billions of suns. The invisible object at the centre of the Milky Way, known as Sagittarius A, is thought to be just one such black hole. It was identified in the 1970s as a particularly strong source of radio signals. Subsequent studies, particularly of the way its gravity pulls nearby stars around, have continued or have convinced us that it is indeed a black hole with 4 million times the sun's mass. Further convincing, but still circumstantial, evidence for black holes came last year with the announcement of the first detection of gravitational waves. Yeah, whatever. These ripples in space-time emanate from very massive objects that are accelerating. For example, two bodies spiraling inwards to smash into each other, for example. The signal observed by the LIGO collaboration in September 2015 was exactly that predicted for the collision and merger of two stellar mass black holes. LIGO has since seen 2 more signals, each compatible with the merger of stellar mass black holes. So is that the case closed? Not so fast, says Rizzola. Quote, although the presence of a binary black hole system is an obvious and simple explanation, it's not the only explanation, he says. In particular, the signals might not come from black holes, but from an entirely different theoretical invention. Now we're going to get into something called boson stars.
Okay, let's hold it right there if we can.
There you go. I can get a drink now, Tony.
Yeah, that was a long dissertation, my PhD friend.
Well, what do you think of that so far? We've got gravitational waves, and now we're moving into another theoretical monster, the boson.
Yeah, I think what we'll do is on CERN, particle physics, DNA, all of those good things that Kev and I have talked about for almost 3 years now. You'll get a really good foundation, as well as current information in the 12 articles that are contained in the 100-page Entangled magazine. So thank you for your hard work and your excellent writing skills, my friend. And a big, big shout out to Robbie and Cheryl, who are the publishers of Entangled magazine. They're the ones that make it look beautiful. They're the ones that put in all the long hours to make it happen. I'm just kind of the ringleader in this 3-ring circus. And I really want to thank the people that have contributed as writers themselves to the August issue and the July and June. And some of the people are right here in the chat room that have contributed their own beautiful writing skills and research. So it's not just Kevin and myself. What we do is provide a platform, a venue for those that might not otherwise have a voice to be able to come to Entangled magazine and spread their opinion, perspective, research, and voice to the world. And I encourage anyone who's listening to this show today to contact me through my contact tab at anthonypatch.com and submit your articles. I'll take a look at them, see if they fit into, sort of our framework of what we're trying to achieve there. And I welcome all, and we'll just take a look at it. So thank you to everybody, and thank you, Robbie and Cheryl, for your huge professionalism. This is top-notch magazine production. Beautiful, beautiful project and product they put out this month.
No,
Take it away, my friend.
Yeah, I was going to actually just second that, because I like to play about with the Photoshop. And believe it or not, when I first got Photoshop, I couldn't even use the thing, right? But to see the kind of finish and the glossiness that Robbie and Cheryl have put to this, I've been blown away by it. The covers of the magazines alone, very striking, so professional looking. And when you add to that the information inside coming from real people and scientists and all sorts of others as well, then it really does all add up to a pretty special publication altogether. Now, Tony, over the time, right, that we've worked together, you have used a word over and over again that I really hadn't heard much. Maybe Alex Jones, he's probably the second biggest user of this word in the kind of on the airways, but hubris. This word hubris, and I know a lot of you out there listening tonight, you followed Anthony maybe from the start or you've picked up somewhere along the way, and he's often referred to hubris. Well, tonight's show is called Hubris, Cracking the Theoretical Paradigm Egg. And I dug up the actual dictionary definition for hubris today, and it's so apt, so fitting, because its first kind of definition is excessive pride or self-confidence. And some of the other words that you could substitute and use in its place are arrogance, conceit, haughtiness, pride.
This is the Kev Baker Show.
Good morning, good afternoon, good evening, ladies and gentlemen. Welcome back. It's another 2 hours of the Kev Baker Show right here on Truth Frequency Radio. And you can find us now at tfrlive.com. Really liking that shorter, snappier kind of web address. I can get easily used to that. But don't fear, because if you've got the old web address saved in your browser, stuff like that, Mr. Geo has set it up so that you all get redirected to tfrlive.com. It's all seamless. Absolutely love it here. And of course, if you hadn't heard already, yes, that's right, I am going for 2 hours every night right here on KBS. And of course, Johnny Whistles, he will be along later on to join us. He's still doing his training for his new job. Proud as heck of that guy. I really am. It's really hard to get employment these days, especially when you've been out of the workforce. So, you know, big up to Johnny for doing that. And the fact we get any of his time at all, to me, honestly, folks, it's an absolute bonus and a pleasure. And of course, there's a third member to this team now, every Monday and Wednesday. And I join forces with him on a Friday. You guessed it, it's Anthony Patch. But there may be some people out there who haven't heard of Anthony Patch. So he's an author, a speaker and a researcher. He's a host here on the network. I like to call him the world's leading cernologist. He's the guy that really has educated most of the world about the true power and the true science of what is going on at the LHC over in Geneva in Switzerland, better known as CERN. He also introduced most of us, I would imagine, to the D-Wave quantum computer and all the fun and games and shenanigans that goes along with that. He's the author of a number of books: Covert Catastrophe, 2048, Diamonds in the Rough, Revising Reality, and I'm helping him, just on the peripheries of helping him, put together something that has turned into an absolutely amazing project. And this is, of course, Entangled e-magazine. Tony, this month's edition, yet again, sir, absolutely amazing. Hats off to you. There's a bit of a download from yours truly in there, but people can find that over at anthonypatch.com. And I tell you, man, you must be putting in some hours putting all that together, Tony.
Well, it's not just me. I want to say a big thanks to you, because your download into this now 100-page magazine is nearly a book. And what I asked you to do was to go back, because you're an excellent writer yourself, and pull from your archives the 12 best articles that you composed from our interviews over the years, and include those in the August issue of Entangled magazine. And they are beautiful and brilliant. And if new listeners to the show want some background on
vanity, self-importance, self-conceit, superciliousness, feeling of superiority, and there's others as well, but then it goes on to say as well, and I think this is very apt, because when they used hubris in the Greek tragedy, it actually meant excessive pride towards or defiance of the gods. leading to nemesis. So this is a word that Tony has used over and over again. And Tony, like I say, you've almost made this word as infamous as Geordie Rose.
Well, thank you for that. I call it being full of themselves. That's my definition.
When I seen the actual definition, I had a rough idea of what it meant, but excessive pride or self-confidence. And when you look at these pompous so-and-sos when they're putting forward their ideas and their theories, no better term befits these people.
Yeah, thank you. I agree. And I love one of the definitions you just read, super silliness. You know what it made me think of is superstring theory in particle physics, as well as supersymmetry when we talk about not only particle physics, but quantum computing. So maybe we should just call tonight the Super Silliness Show.
The Super Silliness Show. That fits for us, Tony. It really does. It might get super silly, but I can guarantee there's going to be so much information contained in here. It's going to blow your mind. And we're going to start off tonight because we're taking a kind of shot at the theoretical paradigms that are out there. And one of the biggest theoretical unicorns that exist in science, and we've spoke about them so much, and I've referenced them. I've said black holes here, black holes there. Well, tonight we're going to attempt to kill the black hole, or at least offer an alternative. And I'm going to read out a story here as well as I can. Anthony's going to interject when he hears things that makes him drop off his chair. But what this is actually saying is that this year, because of the telescopes that they've now got trained on the centre of the galaxy, they're basically taking images of the void at the centre of the galaxy. Now, it's just commonly assumed that that void and all the others like them at the centre of any other galaxy in the universe, it consists of a black hole. But always remember that black holes are theoretical. We've never, ever seen one. So with that said, New Scientist this comes from, and it's actually the author of the story is Stuart Clark. And it says here, fascinating, bamboozling, vaguely terrifying. Black holes are the love-to-hate monsters of the universe. The insatiable cosmic cannibals are concrete predictions of Einstein's general theory of relativity, the best theory of gravity that we have. Even so, theorists long debated whether they could exist, until astronomers saw the first signs of them. Now we see black hole paw prints all over, in huge stars collapsing in on themselves, in distant collisions of massive objects that set the universe quivering, and in the dark hearts of galaxies, including our own. This year, we should have the clincher. The first direct image of the supermassive black hole at the Milky Way's centre. But as we gear up for that shadowy mugshot, some physicists are entertaining a maverick thought. What if it isn't there? The new word is that our obsession with black holes might have blinded us to the existence of something even stranger, a basic phenomenon of particle physics whose significance we have failed to grasp. After all, there's good reason to want whatever is at our galaxy's heart not to be a black hole. For a start, black holes make a nonsense of quantum mechanics, the best theory of everything besides gravity that we have. It's a speculative idea as yet, to be sure, but there are sound reasons to contemplate it. Quote, we scientists tend to be completely arrogant about what we think we know. And that was a theorist called Luciano Rezzolla of the Frankfurt Institute for Advanced Studies in Germany. He goes on to say that I don't want to find myself in 10 years' time saying that it was just another arrogant, overconfident scientist. For all their contemplations, the basic notion of a black hole is remarkably simple. In general relativity, the magisterial theory Einstein produced in 1915, massive objects bend space and time around them, creating the force that we call gravity. An object with sufficiently large mass, densely enough packed, bends space and time so much and creates a gravitational field so strong that nothing, not even light, can escape once it crosses the event horizon. The black hole is a celestial lobster pot, with the difference that it never gets emptied and just keeps on accumulating lobsters, no trace of which is ever seen again. The fact is, no one knows how black holes work on the inside. Relativity suggests that anything that falls in will be crushed by the black hole's gravity into a singularity of zero volume and infinite density. But the prize is still out there for anyone who can say what that truly means. Meanwhile, theorists' most refined calculations show that black holes must either destroy information, which is a complete no-no in quantum theory, or surround themselves in a seething mass of energy called a firewall, which breaks the tenet of general relativity. Black holes represent the point where the very large, the domain of general relativity, meets the very small, the domain of quantum theory, and the results are not pretty. Such problems were already becoming apparent in the 1960s, but that didn't stop astronomers imagining ways for nature to produce black holes.